So this thing is going around Earth at 4.76 miles per second. And I don't know if any of you saw the movie Gravity, when they had those objects in space that were coming through and pelting them. You can realize how dangerous the situation would be when you're traveling this fast around the Earth. So some of you may have just thought, okay, well, I know there's 60 seconds in a minute, 60 minutes an hour, so multiply 60 and then 60 again. I'll get to that way, and that's exactly what you would do. But just to show you to be comfortable with what you learned in chemistry class, with stoichiometry, the same process. So you start off with, say, 4.76 miles per second. And some of you that are taking chemistry or took chemistry are familiar with stoichiometry and how it looks. If you have to go from grams to moles, moles to grams, or grams to grams of a different substance, or number of atoms to number of atoms of another substance if you wanted. So it doesn't matter how many jumps it takes, as long as you use the correct ratios and the correct way to write the ratios, you get to where you want to go. So 4.76 miles per second, and we know that there are how many seconds in a minute? 60. And we want to get rid of seconds and eventually get so that it's miles per hour. So if I write there are 60 seconds in a minute, I could write that either way. I could write 1 minute per 60 seconds, or I could say 60 seconds per 1 minute. But how do I want to write it so that it works out for what we want to do? Yeah.
So 60 seconds per 1 minute.
Very good. 60 seconds per 1 minute. Because if I did it this way, notice the second unit would cancel, go to 1 and 1, leaving you just miles per minute. Okay? So now you know so far at this point, seconds would be canceled. You have miles per minute, and you want to go. You want to get to miles per hour. So what relationship do you know about minutes and hours? There are 60 minutes in 1 hour. So notice, if you do it this way, this is a simple demonstration that you would get to the units that you want. Leaving you, if you go straight across, you will have miles per hour. And if you do this, you do get, what was that, Rihanna? 17,000? 136 miles per hour, which you can also see written as mph, like on a speedometer in a car. So those things move pretty fast, 17,000 miles an hour. Is this the ISS's linear speed or angular speed? Or neither?
Linear speed.
It is linear speed. Good. Linear speed is just like you think about distance over time. Distance over time. So it's distance over time, so it is linear speed. If you are in a car and you're traveling at 50 miles an hour, right, your linear speed is 50 miles per hour.
So is that like constant speed?
You're probably only going to deal with linear speeds that are constant. But speed itself doesn't change. Linear speed doesn't have to remain constant. Like you'll be doing problems where linear speed remains constant. Any questions about what this?
Is this new or is this something we learned?
Were we like starting this yesterday or something?
This is something that, remember when we need to convert degrees to radians or radians to degrees? That's just another demonstration of that. It can, that ratio, I'm showing the use of multiplying by ratios to get from where you start to where you want to, the units you want to be in. Okay? So I thought it was pretty cool if we did a real life example. So let's say you have a car and it gets on average 26 miles per gallon. So it gets 26 miles per gallon. Maybe it's a truck, I don't know. You could write it in PG, but to think of it as a ratio, 26 miles per 1 gallon. Or you could also think about it as 1 gallon per 26 miles. depending on how you're going to use it. So I can't emphasize this enough. A ratio can be written either way. It has the same meaning.
What's the given?
The given on this example I said, the given is your car gets 26 miles per gallon, gas is $2.09 a gallon, and you have $20. How far can you go with $20? That would be like the problem. All right, so again, this ratio can be written either way. It makes sense to say that for every 26 miles you drive, you burn 1 gallon of gas. Or we could read it, for every gallon of gas that you have, you can drive 26 miles. Right?
So do you multiply?
It has the same meaning to be read either way.
How did you get
I made that up. So they give, again, the given information, say assuming you have a vehicle, and on average it's 26 miles per gallon, assuming that the gas is $2.09 a gallon, and assuming that you have you want to know if you spend $20 on gas, everything else remains the same, how far could you drive with $20 under these conditions? So here's a perfect example of how you go from dollars to miles. Okay? So start out with $20, how do we get to miles? Well, we can't jump directly to it, but we can go, we know that $2.09 will give you 1 gallon of gas. Notice how I had to write it. I want the dollars units to go away to 1 over 1, so the dollar unit, you'll no longer see it. Now I would have just gallons, and then I want to go from gallons to miles, which I have that conversion factor. I know that for every 26 miles I drive, it burns 1 gallon of gas. So I use that unit conversion. Gallons go away, and notice I'm left with the unit that I'm interested in, because I want to know how far I can drive with $20. And it comes out, I got 248.8 miles.
How did you get that?
So I got that by just going straight across, using the calculator. You can imagine this is 20 over 1, right? That might help when you're dealing with fractions, just clearly see what to do. So if I grab a calculator and I say, okay, 20 times 1 times 26, so 20 times 26 is 520, all over 1 times 209 times 1. So divided by 209 gives you, if this calculator wants to work, I'll try again. 26 times 20 is 520 divided by 209 gives you 248.8 miles.
I have a question.
Yes.
Are you solving this? Are you just multiplying, right?
Yeah, when you do this, you just multiply in fractions. So you can just go all over this, or you can go 20 divided by 209, whatever that is, times 26. You should arrive at the same answer.
And says, wait, but it doesn't have points.
What's that? Yes.
Okay, so what I'm gathering here from ratios is that ratios are really just based on like what wording you have basically, and that determines which one goes with how, which one goes on the bottom.
Yeah, you could say that. And then looking at here, you can tell, I wouldn't want, for example, I would not want to multiply the first guy. I would not want this ratio to be 209 over 1 gallon, because then I would have dollars squared over gallons. And that makes no logical sense, dollars squared per gallon.
And you wouldn't know that if you didn't have the wording next to it or like symbol. Like
Yeah, the units, yeah, so definitely when you're doing something like this, definitely write out the units so you can clearly see, I know I'm going to use this one, not the written the other way. I know I'm going to use this one, not the other one flipped upside down, the
So
other way.
ratio is required unit.
It's a good idea to be detailed. Yeah.
And you just have to be careful on what you're multiplying by. Like what do you mean like what's the bottom?
Yeah, again, I would not want this to be $209 per 1 gallon, because if I multiply across, I'd have dollars squared, and dollars squared doesn't make any sense to me.
Are you gonna do another problem?
Let's see, the next thing we have in line here is number 89 from the homework. But we could look at, I thought I had, oh, here's an example. So let's say you're given something in degrees, something is 90 degrees, and you want to know how many radians that is. This is more applicable to what you guys are studying, but it's the same idea. You know that 360 degrees is 2 pi radians. So you could write a ratio. You could say 360 degrees, there are 360 degrees for every 2 pi radians, or for every 2 pi radians, there are 360 degrees. Okay? So you want to convert from degrees to radians. So it says given 90 degrees, find theta in radians. Okay? How do we do that? Well, we start with 90. Now, am I going to use this one or this one? If I want degrees to go away to 1 over 1, and I want to be left with just radians. 360 over 2 pi. If I did that, and I went across, I'd have degrees squared over radians.
That's what you,
Oh, that's not.
we use the 2 pi radians over 360.
Right, you can see that here in blue. So I use 2 pi radians over 360 degrees. So that way the degrees go away to 1 over 1, and I'm left with the unit that I'm seeking, which is radians. Yes?
That's the opposite of what we were doing the other day, right?
Opposite of what you're doing?
Like, you know how, wait, let me do that. Oh, never mind.
Okay. So then you just go straight across. Before I go across, I just had to simplify. You can do that, no problem. I noticed that 90 and 360 both are divisible by 90. 9 divided, right? At first I did knock out the 0, that's easy. Then 9 and 36 both divisible by 9, that becomes a 1, that becomes a 4. Then I noticed 2 and 4, they both have a 2 in common, knock those down to 2 and 1. So I just get pi over 2 radians, which is what we should know 90 degrees is pi over 2 radians, yes.
I don't get this because, like, I don't understand the steps because it's already, like, worked out on the board.
Okay.
So, like, I get confused.
Okay, so let's start fresh with one. How about that? Let's go with, would that be good? Okay, so if you make one up, so you want to go, usually we should be really comfortable with either way, but really for what you guys are doing, degrees to radians is probably the best because radians is the most useful. Okay, so you want to give me an example? Let's say that you're given the fact that theta is equal to, you can't think of a random number, 7 degrees, okay? The theta is equal to 7 degrees, and I want to find theta in radians. Okay, so let's say you had a blank slate. Now I will provide to you on the quiz, I will provide to you the fact that 1 revolution is 2 pi radians, which is equal to 360 degrees. Okay? But let's say you didn't know that. Okay? You should know that, but let's say you didn't know that. You'd have to know that, okay, I know 360 degrees is a full rotation, and you just have to know that the full rotation is also 2 pi radians. Okay? What I really meant to say was that say you didn't know the ratio written out. You have to use a ratio to convert from degrees to radians. The ratio that we're using. So which ratio would we use? Would we use, there's two that you know. There is 360 degrees. Actually, let me go ahead and write this in black just to separate what's given versus the actual work being done. So we know there's 360 degrees for every 2 pi radians. And I know that there are 2 pi radians for every 360 degrees. These are both true statements. They're both true ratios.
Use the right one.
Okay? I am going to use the right one, correct. I'm going to use this one right here. Because I want to find theta in radians. So I have a starting value of 7 degrees. I need to multiply this with one of these ratios. You chose the correct one, 2 pi radians. And again, you might see in your work in your textbook where they no longer write radians, it's understood to be radians. So we get to here. And so, if it helps, you could write this over 1, right? Any value can be written over 1. So let's go ahead and do that. So that way it's very clear how we're allowed to simplify, how things simplify, they go away. So the reason you chose this one is because you wanted the degrees to no longer be the unit. You want to just be left with radians. So now it's a matter of simple math, just multiplying numbers.
What is the difference between 2 pi radians over 360 and 360 over 2 pi radians?
Okay, there is no difference between the two. They have the exact same meaning, but you need to choose the one that makes sense.
Would it be
If you're going from degrees to radians, you would use this one. If you're going from radians to degrees, you would use this one. Yes?
Would it be 14 pi radians?
Yeah, so this would be 14 pi radians over 360, but I noticed that 2 and 360 becomes a 1, this becomes a 180, and I don't think I can go any further than that. I don't think 180 and 7 have anything in common.
Oh, you simplified it before you even multiply?
Yes, you're allowed to simplify fractions before you multiply across. Yep. So then I go straight across, and I get 7 pi over 180 radians. Again, you might not see them write out RAD, it's understood to be radians, but I'm going to go ahead and write out radians. I'll write out the whole word. And there you go.
That's not that hard.
Right.
Anyone need more time on this? Okay. So let's go back to, I asked if there's any questions, and someone said number 89. So if you guys want to look at 89, that's probably a good idea. Okay, so number 89, we have, for those of you that have your textbook, on page 496. It reads, the minute hand of a clock is 8 inches long and moves from 12 to 2 o'clock. How far does the tip of the minute hand move? Express your answer in terms of pi and then round to 2 decimal places. Okay, so you think about the formulas that we've gone over, which one is the one that makes sense, and that is this one, that arc length is equal to the measure of the central angle times the radius. Okay, so we're using this S equals theta R. Okay, the only thing is that you don't know what theta is off the top of your head. All you know is that this minute hand went from noon to 2 o'clock. Can you figure out, just from that fact alone, can you figure out what theta is? And the answer is, if you couldn't solve this problem. But they're not going to give you problems that you can't solve. So you got to think, okay, I know something here. If I look at a clock, if I were to divide it up into even sectors, let's say between the 12 and the 1, then the 1 and the 2, and between the 2 and the 3, I would have 12 even, or 12 congruent sectors, correct? Okay. So we could agree that if we went from 12 to 1 with the minute hand, that angle would represent 1/12 of a full rotation. Okay. So if I went from noon, or 12 to 2 with the minute hand, that would represent 2/12 of a full rotation. And that's a fact that we need to state. And we state it right here. We say we are going 2/12 of a full revolution or full rotation, whichever word you want to use. Which of course just simplifies to 1/6.
Wait, how?
How? Because if you were to divide the clock into 12 perfect sectors, each one of those sectors represents 1/12 of a full rotation. Okay? So if we go from the minute hand from 12 to 2, that would be 2 up out of all 12, or 2/12 of a full rotation. Okay? So we know 2/12 of a full rotation, or 1/6 of a full rotation, simplifying it. Well, we need this to be in radians. By the way, all of these formulas that we are using, when there is theta involved, it's all radians. It has to be in radians. And that's what we have to do. So what is the angle measure of an angle that is 1/6 of a full revolution? If a full revolution or full rotation is 2 pi radians, 1/6 of that, and that's what I say, theta is 1/6 of 2 pi radians. Notice I didn't have to write the RAD at this point. Like I said, it's understood to be in radians.
How do you multiply by 2?
I multiply 1/6 by 2 pi because 2 pi radians is 1 full rotation. And what we have is not 1 full rotation, we only have 1/6 because the minute hand is only going from 12 to 2 for this problem. For example, if the minute hand went from 12 to 12, that would be a central angle measure of 2 pi radians. If the minute hand went from 12 to 6, that would be a central angle measure of just pi radians. If it went from 12 to 3, 1/4 pi radians, and going from 12 to 2, 2/12 or 1/6 of a revolution, or 1/6 of 2 pi, which is pi over 3 radians. So you need to think about when you have problems that deal with rotations. This is what fraction of a full rotation. And if you know a full rotation is at 2 pi radians, then you can figure out whatever the central angle is. Yes, Maya.
What is the first step? Like, which one do you do first?
Alright, so the first step was to write this formula down, because I know that or pick this one out. Because you might write all 4 or 5 formulas that you know and say, okay, which one am I going to use? If I want to know, I have to figure out what am I finding. I'm finding this. I'm finding arc length, what's here in red. I'm finding arc length. This is arc length in terms of the central angle measure and the radius. I'm given this. This is R. This 8 inches, that's R. I don't know theta off the top of my head, but I can easily figure it out, the fact that I'm going from 12 to 2. And I want to find this.
How do you find it?
So how do I find it? I find it using this formula right here. Because this says arc length equals the central angle measure in radians times the radius.
So what's the R? How do you measure the arc length?
I don't know the arc length, that's what I'm going to find. Okay, so I first needed to get theta because the radius was given. It told me the length of the minute hand is 8 inches. So R is 8. Okay? So theta is pi over 3 because of what I discussed about understanding 1 full revolution is 2 pi radians, half of a revolution is pi radians. For us, 2/12 of 2 pi is pi over 3 radians. How do you what? How do you find what?
What you just said.
The pi over 3 radians?
Yeah.
Okay, so let's go over this again. So you guys,
Not saying like, right here it says 1 over 6 plus 2 pi.
yep.
And then what did you do?
Oh, just multiplication. 1/6 times 2 is 1/3. 2 6 is 1/3.
Oh. See, I was confused because I didn't get the steps. Like I see that you did that first, and then you plugged it in. I thought you were plugging the S equals pi over 3.
Yes. So I had to figure this out before I could then plug it in. Okay. So good question.
Wait.
Okay. So we got pi over 3 for our theta. R was given at 8, so now we just simply plug it theta, pi over 3 radians for theta, plug in 8 for R, simplifying, which is just going to be 8 pi over 3 inches. And then if they want it into 2 decimal places, you actually use the pi key on your calculator, or 3.14, or 22/7, and you get S is approximately 8.38 inches. Yeah, I believe, yes.
Okay. So, I'm kind of confused. Okay, I get actually the box where it says S equals 8 pi over 3 inches. I get that, so you just put that in.
Okay, so you're done.
But I'm saying I don't get the part. The theta equals 1/6 times 2 pi equals pi over 3. And where did that come from?
That comes from the fact that you know when you go from 12 to 2, you've gone 2/12 of a full rotation.
Okay, but what does that have to do with it?
That's how we found the little cubic thing.
So yeah, I gotta find theta.
Oh,
Okay.
wait, so is that given? That's not given.
No, the information that was given in the text was that the minute hand went from 12 to 2, and it's 8 inches long.
Okay.
Find the arc length, or the distance that's covered by the tip of that minute hand.
When you're reading the problem, how do you know which part is the radius?
How do I know which part is the what?
The radius.
The radius.
Based on R equals 8.
Yeah, that's the radius. That's the distance from the center of the clock all the way to the edge of the clock. Because it tells me that
So whenever it say how long something is, then that's what you mean.
if that is the radius of what you're talking about. Yes.
How do you get an equal 8.3?
Oh, that was just using pi is approximately 3.14.
You want us to simplify like all the way to them?
Well, this is the exact answer. They wanted both for the normal
okay.
problem. They said, well, give it in pi and give it in terms of rounding to decimal place. Okay. Do we need more time on this one?
No. Okay, I'm gonna go level up that.
I'm trying to write it down.
Okay, good.
Need more time?
Yes, you can have my paper.
All right, thank you. Okay, so someone had a question about 97. So, guys, please. So number 97, it talks about the angular speed of a point on Earth is 1/12 pi radian per hour. The equator lies on a circle of radius approximately 4,000 miles. Find the linear velocity in miles per hour of a point on the equator. Now for this problem, I wrote down a bunch of information that we now know, that we've now studied up to this point. You have to be able to figure out which of these you want to use, if not a combination. Now for this quiz that we're going to take on Friday, it's going to be simple problems to where it's something just the use of one of them. I'm not going to give you any regular problems where it's a combination of this and a combination of that. It's going to be just the use of one formula. So, for this problem, they're talking about linear velocity, and they want you to find linear velocity. They want you to find, that's a V, not an R. They want you to find linear speed, and they give you angular speed, and they give you the radius. So it's just the use of this formula here. Because this says that linear speed is equal to the length of the radius times the angular speed. So this W, angular speed, has the same meaning as this W here, angular speed. Yes, Jemima?
How do we just jump from one thing to another?
What's that?
We were just doing something completely different.
Because the previous problem dealt with this formula here.
No,
So this formula here says arc length is equal to theta, which needs to be in radians, times the length of the radius. This formula here says that linear speed needs to be equal to the radius times the angular speed. Angular speed needs to also be in radians per unit, whatever you're talking about. What's that?
It's going to be up for one.
Yeah, this whole taking
You
the
said
picture
you have a
thing.
quiz on this on Friday?
What's that?
You said, okay, I have a quiz.
Yes, we have a quiz on Friday that will be over being comfortable converting degrees to radians, radians to degrees, knowing. Now, I will provide these on the paper, at the top of your paper, but you need to be comfortable enough to know what this one means, what this one means, what this one means, and what this one means, which is part of what, we're talking about today. So V is linear speed.
So linear speed.
Yeah.
Can you write that down?
Yeah. So V is linear speed. So this is in the notes that we did, I believe, last class.
Can we stop talking?
Yeah, guys, the talking doesn't help anyone. It really doesn't. So T is time. That's correct. So V is linear speed. So for those of you that have your textbook, it's very helpful to go to page 493 to review what we talked about last class, which talks about linear speed and angular speed. Okay. This was the first of all these formulas. This was the first one that we talked about, I think, towards the beginning or middle of last week.
Can we put the formula, what it means, and then the problem under for each of those
I think by me providing all these formulas is being very kind.
Wait, so, no, I'm talking about linear speed. R equals W equals.
Yeah. So W is angular speed. So I'm just gonna, I guess, without sounding too robotic, I don't know how to go through these without just going ahead and repeating them again. But again, we have gone over these last class. So what we'll do is, yes. What's that? Yes, go ahead. Yes, Mars.
This is a little bit off topic.
Then I don't know if it needs to be said. It needs to relate to what we're talking about.
Well, it is kind of like math, kind of. It's just a person.
The equation from the last line. Okay, so we're going to go back to here. I multiplied 4,000 by pi over 12 to get 1,047.
And I did that and I didn't get it.
Okay, then you need to practice with your calculator.
I divided by 2. I got 0.22.
You have to do them separately, not calculator. You have to do 4,000 times, the 4,000 times 5, get that answer, then divide that by 12.
Or you can do 4,000 divided by 12, get that answer multiplied by pi. It's all the same.
Opposite is the line.
That was going to be second. Any questions about SOHCAHTOA?
The opposite
What's that?
opposite is B, right?
Opposite of what? Alpha?
Hypotenuse.
Opposite of what?
Hypotenuse.
Opposite of the hypotenuse? You don't like say that. I don't know what you're asking. What are you asking?